welcome back to our notes for writing trig equations given their graphs. And in example 3, we're asked to write a secant function, and the graph we need to assume has no reflections, which tells us that the A is going to be positive, and assume that there is a phase shift to the left. So if I want to find the A value, I need to know the relative max and relative min. My relative max is down here at -9. The relative min is up here at +3. So the A, it's positive because there's been no reflection. So we have an absolute value of -9 minus 3 all divided by 2. And -9 minus 3 is -12. Then we're going to divide that by 2 to get -6. And the absolute value of -6 is +6. So the A in our transformation equation is going to be 6. Next, we're going to look for the B. And to identify B, we take the period of the parent graph, and the parent graph of secant has a period of 2 pi. And then we need to divide that by the period of the given function, which would be the distance between the extrema or between the asymptotes. Remember, we have a vertical asymptote here between each of these u's, and one cycle of secant would be a downward facing u followed by an upward facing u. So that would be a period of pi over 2. So we're taking 2 pi and dividing it by pi over 2. And when you divide by a fraction, you multiply by the reciprocal. So that's 2 pi times 2 over pi. The pi's cancel and leave us with a 4. So B is equal to +4 in our transformation equation. Okay, next we'll identify that vertical displacement. And we can see the vertical displacement on the graph as the midline of the graph. The half the distance here between the extrema would be at -3. That's my midline. I can find that using this formula. K equals the maximum, which was -9, plus that relative min at 3, and then divide by 2. And -6 divided by 2 is -3, which matches that midline that we identified in the graph. Okay, then we have the H. It tells us that there is a phase shift to the left, H coordinates, and it's easiest to see that if we graph what we have so far. So we'll go to the y equals, and our equation with no phase shift would be 6 secant of the quantity 4x. We'll just leave a space here for the phase shift, and then our vertical displacement is down 3. So there is no button on the calculator for secant. We have to use the cosine, since secant is the reciprocal. We'll take our A divided by the cosine, and then 4x is our argument of the function, and then -3. We'll hit window button, and we're going to set the window dimensions to match the graph that was given. So that lower bound on x is -pi. Upper bound is 2 pi. We're going in increments of pi over 4. Then the lower bound on the y, let's see, these are going by 3's, so -15. Upper bound would be a 9, and the increments are 3's in the scale. So we'll click on graph, And on the TI-83, you get these lines in between that look like the asymptotes. If you're using the TI-84, that won't be such an issue because it doesn't show all those lines going back and forth. So if you, in either case, if you hit the trace button and you pick a point on this graph to use as a reference, so at pi over 8, I should have a relative maximum of -9. And if I didn't have a phase shift, so if I type pi over 8, notice I hit an asymptote. And I want to hit -9. So since it's hitting an asymptote here instead at pi over 8, that means I would need to phase shift pi over 8 to the left in order to make these graphs line up. So I'm going to go ahead and make this a pi over 8 for my h. Okay, and then I'll fix my equation to phase shift to the left, pi over 8 units, and then my displacement down 3. We'll hit graph, and then we'll try the trace button again once it finishes graphing and see if it lines up now. So trace, now this time when I enter pi over 8, instead of an asymptote, I should get my maximum here of -9, and I do. There's my y equals -9. Okay, if I put in, let's see, this would be 1 pi over 8, 2 pi over 8, so 3 pi over 8 should be a relative min of 3. So let's type in 3 pi over 8, and there it is. There's my relative min of y equals 3. So now I can tell that this equation is the one that produces that graph. So at this point, you're going to pause the video and try example 4 on your own, where you're asked to write a cosecant function for this graph, assuming that there is no phase shift. And when you're ready to go over the answers, we can resume the video. Okay, so when we take a look at this graph, we're going to use these relative extrema. So here's a relative minimum of 3 and a relative maximum at -1. Okay, to find the A, we're going to take that max minus min, so -1 minus 3. We'll divide that by 2 and then take the absolute value. So -4 divided by 2 is -2. The absolute value of -2 is +2. And so our A is going to have a magnitude of 2. Now we need to decide, is it positive or negative, and that's based on the reflection. So if we take a look at the parent graph of cosecant, okay, that's the reciprocal of the sine function, and sine starts at 0, then goes to its maximum, back to 0, down to its minimum, and back to 0. So this would be, we'll dash it in, the parent graph of sine. Everywhere that sine has a 0, cosecant has an asymptote. And then the extrema of sine, the absolute extrema, become the relative extrema of cosecant. And then we can go back and erase those guidelines for the sine graph. Okay, and that would be one cycle or one period of the cosecant function. So since cosecant has an asymptote here along the y-axis, just like our function that we were given does, but then it starts facing up, and our function has a u that's facing down. That means that there is, in fact, a reflection in the x-axis, and that tells us that the A is less than 0. Okay, and that's because we're told to assume no phase shift. So the only way that I can get this upward facing u to become a downward facing u is if I have a reflection in the x-axis. So this A is going to be -2 to account for that reflection. Next, we're going to find the period of the graph, and that would be from my vertical asymptote here along the y-axis to the next asymptote is here at 2 pi, to the next one, which is here at 4 pi, and the period is the distance from the y-axis to the end of that first cycle before it starts to repeat. So we have an upward and downward facing U makes one complete cycle, and that's from 0 to 4 pi. So the period of this graph is 4 pi. To find the B value, we take the period of the parent function, and cosecant has a period of 2 pi. We divide that by the period of this graph, which is 4 pi. The pi's cancel, and 2 over 4 is a B of 1/2. So you can get that equals the right way. There we go. So B is equal to 1/2. Next, we're going to look for the vertical displacement, and that's found by averaging our extrema. So K is equal to the max, -1, plus the min, which is 3, all divided by 2. And so K is equal to 1. And we can see that K as the midline on the graph, right, halfway between our relative extrema. Okay, now we're going to put those pieces together. So we have y equals -2 cosecant of the quantity 1/2 x plus 1. And then we'll put that into the graphing calculator and check our answer. So if we go to the y equals -2, there's no button for cosecant, so we do the reciprocal of sine, and then 1/2 x, and that's plus 1 for the displacement. Then we're going to go to the window and adjust our window settings to match this graph that we were given, which is going from -pi to 5 pi in increments of pi over 2. Then in the y direction, -4 to 6 in increments of 1. Okay, between these alternating up and down U's, we see the TI-83 calculator connects those ends, making lines that kind of look like asymptotes between. If you're using the TI-84 calculator, you won't see those vertical lines in the place where the asymptotes are located. Okay, so here you can see the TI-84 calculator screen, and there's no dashed lines or solid lines between indicating the asymptotes. Okay, so if we compare this function now to the one that we were given, we'll hit the trace button and see if this relative maximum is located at -1. So we put in pi for the x, we get back -1, that matches. If I type in 3 pi for my x, I get back +3, which matches that relative minimum in the graph that I was given. So we can see that no phase shift was needed, and it did tell us up here to assume no phase shift. So the h is equal to 0, and our equation is y equals -2 cosecant of the quantity 1/2 x plus a displacement of 1.